It's about a star 93 million miles away, and how much of it your body can survive. Strip away every stitch of clothing a human has ever worn, the sunscreen, the hats, the shade, and what's left underneath is a survival tool your ancestors spent 2 million years engineering. Most people think skin color is about race. It's not. Go back roughly 2 million years to East Africa. Humans had just lost most of their body hair. Bare, sweaty skin built for endurance running under a brutal equatorial sun. And bare skin under that sun should have been a death sentence. Every hour outside should have destroyed the folate in your bloodstream, a vitamin your body needs to make working sperm, healthy red blood cells, functioning embryos. You get a sunburn after an afternoon at the beach. Your earliest ancestors faced that same sun, at that intensity, every single day of their lives. But nobody figured out how skin survived it, until someone looked at it under the wrong kind of light entirely. A researcher staring at skin cell samples under UV light noticed something the old theories missed. Melanin wasn't blocking sunlight to change appearance, it was stopping UV rays from tearing apart folate at the molecular level. That's the folate protection model, published by Penn State anthropologist Nina Jablonski, in 2000, and it flipped the field. Dark skin wasn't decoration. It was armor against a deficiency that could end a bloodline in a single generation. But here's the part nobody talks about. That same armor becomes a liability the moment you move. Head north, away from the equator, and sunlight gets weaker, scarcer through the year. Skin built to block UV starts blocking too much of it, including the UV your body needs to manufacture vitamin D on its own. Populations that pushed into Europe and northern Asia were suddenly deficient in the very light that once threatened to kill their ancestors. So the shield had to thin out, and this is where it gets stranger. It didn't happen the way you'd expect. In a 2017 study sequencing over 1,500 genomes across Africa, geneticist Sarah Tishkoff and her team found something nobody predicted. The DNA variants for lighter skin were already sitting inside African populations, thousands of years before anyone left the continent. Evolution didn't invent light skin from scratch in Europe, it was recycling variation that already existed at home. But Africa wasn't the only place solving this problem independently. Two skeletons pulled from caves in Spain and Belgium decades apart carry a signature that makes the story even stranger. Sequenced by researchers in 2007, the genes show Neanderthal pale skin evolved through mutations completely different from the ones in modern humans. Two branches of humanity, thousands of years apart, arrived at the same answer to the same sun problem, using entirely different genetic tools. Here's what should stop you completely. Your skin color isn't a fixed trait passed down like a family heirloom. It's a live negotiation your genome is still running between two threats that never fully go away. Too much sun destroys the folate you need to reproduce. Too little starves the vitamin D you need to survive. Every skin tone alive today is a different settlement in that same negotiation, tuned to how much sun a population's ancestors stood under for thousands of years. So that settles it, right? Closer to the equator, darker skin, further away, lighter. Not quite. And one population breaks the pattern completely. The Inuit get almost no direct sun for months at a time, yet kept relatively dark skin. Skin that, by every rule so far, should have gone pale generations ago. It didn't. Anthropological studies of traditional Arctic diets point to why. Fish and marine mammal fat, naturally loaded with vitamin D, meant their skin never had to lighten to catch UV that wasn't there anyway. The sun wasn't the only variable in this equation. What was on the plate mattered just as much as what was in the sky. We traded a life spent almost entirely outdoors for one spent almost entirely indoors, and never knew what we lost. Vitamin D deficiency today is one of the most common nutrient gaps on the planet, in people of every skin color. Every country that stopped living the outdoor life their ancestors' skin was built for. Right now, in a population somewhere you've never thought to ask about, that same 2 million-year-old negotiation is still running, quietly rewriting a genome, one birth at a time. That star is still writing your skin. It just hasn't finished the sentence.